Welcome everyone to August's Stuck in a Bucket webinar series. Hopefully everyone can hear me okay. And hopefully we'll have good luck with new platform running through Teams rather than the Riverside platform. Hopefully everyone can see a shared screen here with the intro screen. So looks like we've got quite a few folks on. We'll go ahead and get started rolling through. All righty. So today's webinar is hosted by myself, Fritz Wichern. I've got Dan Kokinda, who's one of our senior sales engineers, joining us, and as well as Dave Gardner, who's our new area VP for the Western region. So if you're out that way, be looking forward to getting to see him and getting to know him a little better. In this month's webinar, we're going to explore a little bit of just a small taste of some advanced control basic functionality. We're going to be looking at passing point data, the NetPoint cache, and COV functionality for getting your point data from one controller to another. We're also going to look at some different ways to enable PID loops and control some of the different parameters of PID loops. Seems to be a common question that comes in here and there. And then we'll have a question and answer session at the end to kind of follow up. So, and also make sure to keep an eye on your email afterwards. As usual, there's a little KMC etiquette that gets sent out to one lucky attendee. So everybody could use another coffee cup, right? All right, so to get started, we'll talk about point basing or point passing. But the basis of all this, right, is our control basic, is the programming language that we use in all the KMC Conquest controllers, right? You can write programs and evaluate, modify objects on a controller, send communication messages across the BACnet network. All of the KMC Conquest controllers are peer-to-peer. So any controller can read and write points to any other controller on the network. And with this communication model, it enables seamless operation between the devices. We refer to the point passing as reading and writing values between controllers and devices in the network. If any controller needs to share values, right, it either needs to send data or read data. When it's reading data, the controller generates a request for information from another device. So if we're reading, say, an outside air temp sensor from another controller, request is generated, sent to that controller with the outside air sensor. That controller then takes that outside sensor reading, receives the request, and then replies with a message containing that outside air temperature. Same thing, basically just the opposite with writing the data, okay? If the controller has a code to write to another controller, the destination controller will be sent a message with the data specified. So a controller may send occupancy info to another controller across the network. The receiving controller updates its object information. Operation of the receiving controller is then influenced by that new data. If you're monitoring values on the receiving controller, you may see updated values, but not necessarily know where they're coming from. So that's one advantage to the reading or pulling data, is if you're reading that data and you can see which controller you're actually pulling that from, the controller and the point. We'll get into a little bit of the code here in a minute to explain that a little more. But the biggest thing with, any point passing, setting up logic to communicate VAV information back up to an air handler is just to be able to be consistent in the way that you and your techs are writing the code to really try and increase that efficiency and then reduce any of the troubleshooting time down the road that you're going to have to go through to figure out any issues or errors. So, but one thing to note, whether you're reading or writing data, the network traffic generated is still the same, one way or the other.
If I can touch on something here real quick, Fritz.
Yeah.
It's a best practice thing on point passing, and you may have covered it in another webinar, but let's say you're sending outside air temp, and you want to send it to all your controllers, and let's say you've got 5 different networks. You could be sending that to 100 different controllers, or reading it from 100, 100 different controllers are reading. You don't want to hammer that one device. So our recommendation is if you have 5 different controllers, have one controller on each of the 5 networks, read it from where the point is, and then each of those networks can then pull that controller, just to kind of share the load around a little bit. So anyway.
Sure. Yep, that's perfect. Thank you, Dan. All right. So starting off, we'll take a look at the kind of most simple form of passing data. Right. So we've got an example here where we've got an interval set up that's going to say every 10 seconds, I want the program to run this subroutine of VAV load. That routine is going to go out and read the points that we've specified, loop 1 and loop 2 on the VAVs located at, in this case, addresses 33 and 34 on our network. These values are written to the variables on our controller AV1 through AV4. When the program gets to a line of code that references an off-panel point, a network message is generated. There is a wait command in between each of the device instance and code. The wait forces the entire program, and I apologize, it sounds like my dogs are going crazy downstairs. I don't know if y'all can hear that or not, but that wait command between each device instance forces the entire program to wait a specified amount of time, in this case 1 second, but using that wait command throttles the number of messages or requests that are put out on the network and allows us to keep our network moving quickly. We're also grouping requests to the same panel, so the controller will use read property multiple rather than the read property messages, again, limiting the total number of messages that are pushed out to the network. So when we're using a wait command, the entire program will wait that specified amount of time. No other code in the program will be executed during that duration. This is why you should put all of your off-panel reads in the same program and have program sequence in other programs.
If I can, Fritz, too, just to reinforce, if you go back, just to reinforce what you're saying here. It's kind of obvious, but you've got the interval 10 seconds and the wait. And then I know you're going to show another method of doing, the same thing. But I can't tell you how many times I've gotten asked to go in, my controllers aren't talking, whatever, and people do not have timing control in their code. They'll just have like lines 8, 9, 13, and 14, and that's it. And if you don't have the timing control in there, you're going to be hammering the network. We've got some stuff under the hood that helps out with that, but like I said, I've seen countless times where networks come to a crawl because people don't control the timing. So anyway.
Well, so we're moving up from just that simple point passing to the NetPoint and NetPoint cache functionality here. So the biggest point in this is if you determine you have the need to receive or transmit values to other controllers, then really that NetPoint cache and NetPoint functions are the most efficient way to accomplish this. So the NetPoint creates a local cache for off-panel values that can be referenced from other programs. NetPoint and NetPoint cache should always be used together. This helps to manage the timing of any off-panel requests, as the controller will handle the wait and interval functions in the background. The NetPoint is a global command, and you should only execute them once in a program. If a point is read-only, right, on that second part of that syntax, we would use a NaN value in there in the right interval field, and we'll look at the actual syntax setup of that point here in a minute. NetPoint cache remembers the last values received or written to or from off-panel points. And then NetPoint cache is not global and must be used in each program. So let's take a look at an example of what this code would look like here. So, initially, here's some folks that will kind of, give you the idea that, it's a little more complicated. But really, it's not. There's not anything tricky or crazy to this, right? So in this instance, what we're looking at is the NetPoint. It's going out. It's grabbing device ID. It's looking at the two loop inputs, the cooling and heating demand, and then the interval for the time for what it's going to grab those points, right? So every 10 seconds, that cache in the controller will update automatically, and it's going to reduce the time needed to execute the control basic program. Up at the top there, we've got the power loss statement, which ensures that the NetPoints are the only set up once following a power loss or restart. Now, one key part to using NetPoint and NetPoint cache is that this NetPoint cache, parentheses of 1, is what's actually going to enable that caching on your controller. It's got to be added to the logic prior to any of the code using that data. The NetPoint cache must be enabled, right? We mentioned that. If you want to use the points in program 2, you will need to turn on NetPoint cache in that program as well. And then as a general rule of thumb, using point passing and NetPoint, really you want to kind of start small, test your logic, compile it, make sure it works before you start to go out and grab, data from a string of 30 VAV boxes to pull information back on all those. So get it worked out for a couple of VAV boxes and then go from there. Anything I missed on that one, Dan?
Nope.
It was pretty straightforward, right?
Yep. So you do have where you only run the setup code once, right? I didn't pay attention to that.
Yes. Yeah.
Yep, it's power loss. Yep. Okay. Just making sure.
Yep. So you just want to do that once.
Yep. Okay.
All right. So here we're actually going to look at the breakdown of the syntax for that NetPoint. So it starts off same as the others. You've got a device instance. Next, you're going to look at your object property, whatever you want to look at, whether it's the present value of your loop 1 or loop 2. If you want to look at an analog value, a binary variable, whatever it may be. The next piece in there is that read interval in seconds. The default value there is it's set in the little tables, defaults to 60. And then write interval is if you're using or if you're pulling data from anything other than a read-only point is where that would come into play. And then the NetPoint cache expression is pretty straightforward. 1 to enable, 0 to disable NetPoint cache. All right. So we'll go ahead and step on. So the next step up from the NetPoint cache is actually pulling in the change of value options, which gives us a lot better or tighter kind of response. So if you've looked at, your programming, your job site, your functionality, what you need, and you've determined you need to receive or transmit values to other controllers, right? You say, okay, we're going to use NetPoint cache and NetPoint functions, because those are the most efficient way to get this done. But we may want feedback. So if you need that feedback quickly as possible from an off-panel point, then you can add in the COV or the change of value to NetPoint as an option. It's not required with the NetPoint cache, but it's kind of a step up and gives you an extra little level of information, right? One thing to note, not all BACnet controllers support change of values, so that's something to think about when you're writing code. If you have a trunk that's mixed controllers, but all the KMC Conquest line does, so anything, if it's all KMC, you're good to go. So looking at our program here, we've got the change of value, where we're entering a value in seconds for the lifetime of the subscription. In this case, the sending device will continue to send that change of value until the timer expires, right? So in this case, we're going out and looking at device number 5, BV1, that present value, and then it's going to run for 300 seconds. If you enter a 0 for that confirmed subscription COV, each time the controller receives a COV message, it replies to the sender. If that sender does not receive that confirmation message, it will attempt to resend it 3 times. If you enter a 1 for the unconfirmed subscription COV, then you get no confirmation message sent back to the sender, or sent to the sender. So one thing, a couple things to be aware of with that local cache value is it's updated when the controller resubscribes to COV. The controller does a read property because of the NetPoint time interval. And then the remote point changes and exceeds the COV increment amount. Let's see, I think that pretty much covers it there. Anything else on that one, Dan?
Nope, sounds good.
Good. So looking just a little bit deeper right into the breakdown of the syntax for our COV here. Same as the NetPoint, we start with the device instance, the object property, what we want to look at. Present value is typically what's used most of the time. Your lifetime in seconds, right? And then your confirmed, and then the increment amount to be added there.
One thing I'll mention is you really should only use COV for binary objects. If you do analog and you set your increment too low, if it's like a space temperature or water temperature or something like that, or whatever it is, if it changes too frequently, you will flood the network and the devices.
That's true. That's a very good point. All right, so moving on from our NetPoint and NetPoint cache, passing point data around, we're going to actually jump over here, and we can just take a quick look at a couple live programs, right? That's pretty straightforward stuff. This is a simple point passing functionality here. Dan, can you see my connect window here?
I can.
I want to make sure that I'm sharing
Yep.
the right window, right? So this is just a simple point passing where we're saying AV30 is equal to another device. In this case, I've got it set up linked to VAV 1201. It's pulling in the cooling and heating demand, right? So it's going out and pulling those values in. Right now, everything's pretty kosher in the office on a test panel here, so there's not a lot going on with the VAVs on my panel over there. But this is an the most basic form, a way to go out and grab point data from another controller. This is a reference or an example of that step up that we looked at, where we have the NetPoint and NetPoint cache. So anytime you use NetPoint and NetPoint cache together, remember that it needs to be enabled in that program. In the same way, this is going out, looking at my VAV 1201, loop 1 value, present value, and passing that data along and saving it here. So again, this is just a little more reliable and efficient way to run that and get it going. So now we're going to step over, switch back here to my slideshow. And we're going to look a little bit at PID loops and some of the different kind of functions and options you have for controlling the different properties and disabling them. So one thing, if you want to write the proportional of a PID loop from a program, you can write directly to it into a program by setting the value as noted here. So you can actually set the value in your program if you want to. An alternate is to actually set that proportional value to an analog value, and then you don't have to go into the program itself to change your proportional value if you're trying to tune your loop. You can just adjust it through an analog value. And then here we've got another example, is a method to enable and disable your PID loops by writing to the proportional value if the unit is occupied. So in this case, we're just looking at occupancy status. And we've got a couple different examples that I've got pulled up in Connect of different ways to do this, but it's essentially just saying, if BV5 is true, then my proportional value is equal to whatever I have set up on my analog value. If not, then it's 0. So then my PID loop, loop output is going to drop to 0. This one is just a little bit of loop manipulation that I believe this one came from Gene as a way to slow down a loop that may be starting out and controlling fast. You can add in some variables here to be able to slow it down as far as how fast it's increasing or descending by taking a look at the fan speed and then this analog fan variable to calculate that out. So, but let's go switch over here to our Connect. And let's pull up. Here we go. So we've got an example here of that same, kind of first options that we looked at, right? VV is true. You turn the proportional value and set it to 4 or whatever it may be, calibration factor. Another option, this is one, Dan, that you had, I think, just mentioned earlier that you use. One option is to, set your integral value, right, equal to BO2. So if this was, you were saying if it's the supply fan start-stop, is that correct?
Yep, correct.
Yep.
Or anything. I mean, you could do, let's say you're doing economizer, you could have the supply fan on there, you could have econ mode on there, you could have occupancy, and you could do BO1 times BV1 times BV7 times AV50. So you can put as many binaries in there, and if any one of the conditions is false, then it'll plug a 0 in. Can't remember if you touched on that or not, but the whole point of doing this is to prevent PID loop windup.
Yep. And so in that case too, right, you've got either a 1 or a 0. So as that multiplies out, where that comes through. Another step up, one thing I hadn't thought of that I'm glad you mentioned earlier too was the error level, and making sure that the information you're going out or the data you're going out to pull is actually valid data, and not just gonna give you some screwy numbers and not work the way you want it to. So
Yeah, if you have a power outage or something like that, it takes a little bit for the network to stabilize, and you'll actually get a NAN back when you do your reads, and you may get unintended code execution if you don't account for that. An error level equals 0. It basically says you've got good data, because it can actually be I think with ours, a 1 or a 2, which is like com failed, or don't quote me on this, but I think it's like com failed, or like is NAN. There's different cases, but anyway, if it equals 0, it means you have good data.
all right, okay. Sounds good. Well, it looks like we've got a few minutes left here. I haven't been watching the chat, but are there any questions that we need to answer, or we can, if we didn't get answered, we can follow up after the fact? Then were there any in there that you wanted to bring up?
I've got the questions handled in there. I'm 99% certain. So when you do a NetPoint definition, whether you use either none or NAN, I think you can use either one in that instance, if I remember correctly. It's been a while since I've done that. And then somebody had a question about flooding the network, because of course, IP networks, well, they're a lot faster than MSTP, and that is true. But at the same time, you've got overhead, and you don't want to run wild if you're doing point passing. It's just the best practice to pull your data no faster than you really need to. If it's a space temperature, you don't need to know it every 5 seconds. Get it every minute or every 2 minutes or something like that, and just evaluate all your data. And if you're going to try to do, even with IP, I've seen somebody try to control, they had a pressure transducer, a water pressure transducer, for a freight drive, a hot water loop, and the pressure was on a different controller than they were controlling the freight drive output. And I don't care how fast your network is, it just doesn't work. They were never able to tune their loop and achieve a stable set point control. So there's different considerations on how you do stuff like that. If we have a second left. You had on your last line of code there in Connect, you had that 1.0 thing. I don't know if you want to mention that or not, but that's something I've seen, not often, but I've seen it come up. And just to touch on that real quick, that line 18, if you do math in Control Basic I think this starts in Gen 5 Conquest controllers. If you do math, it's the divided by 36. It's the divided by or the multiplies. If you didn't have the 1.0 times in there, you would only get an integer value in your AV. So that's doing elapsed active time, and it would plug in 5 hours, even if it was actually 5.27. I don't remember the reasoning behind the underlying code, but you have to put a float in the statement if you've got math involved in something in order to get it to actually read 5.27. Or I haven't tried this, but I think conversely, you could leave the 1.0 times out and you could just put divided by 3600.0, and I think that'll do the same thing. But if you ever see weird results because you only have an integer, check and see if you're doing math. And if you are, add a decimal point in there, just a 0.0, but put a decimal in there.
All right.
A couple of questions came up. Is setting the integer to 0. So setting the integer value, integral value in a loop, it actually resets everything to zero, so you're starting from scratch. So yeah, that'll reset the controller. Or not the controller, but it'll reset the I portion to zero, and like, yeah, you'll start from scratch. So read run times, depending on how many devices you're reading. That's a good question about staggering run read times. Fritz, do you have I gotta think about that for a second. About Kevin's question.
Oh, let's see. Stagger the read, run times, and NetPoint, depending on how many devices. Yeah, they're. I will look that up. So I have read that. Yeah, I think you want to limit. You know, you don't want to just go crazy with it, but.
And you don't want, I think, everything set to the same value, because you'll end up being bursty, is how I've heard it described with your communication.
Yep. But we can double check with that. And
Yep.
One nice thing, you know, like I said, with Teams now, we've got a better list of attendees and the questions that y'all have, so we can follow up with you, Kevin. Jeffrey, we can definitely get a copy of the slideshow sent out. You know, one thing to switch back over to that I was just going to mention, you know, if you haven't gone out and subscribed to the KMC Controls YouTube channel, there are a whole lot of videos out there that cover everything from details on controllers to, you know, PID loops to control basic.
Yep.
Lots of videos with Dan out there leading the training. So a lot of good stuff out there, a lot of good resources. And then one last thing to mention, if y'all have any other topics you'd like us to cover, you know, feel free to shoot myself an email, or you can always comment suggestions on the LinkedIn posts when we send that out. So be happy to hear them, and always interested in you know, touching on what y'all want to hear and learn. So our next month's webinar is going to be Friday, September 27th. Looks like we're going to be doing a couple series or a couple months on some exciting Niagara stuff coming up. So something to look forward to. But I think we'll call that a day, wrap it up. I appreciate everyone jumping on, and everybody have a great day.
Thank you, everyone.
All righty. Thanks, guys. We'll see you.